Okay, so this problem says semicircle POQ. So there's POQ, POQ. Okay, semicircle, and ROS, ROS. This ROS. Okay, there's two semicircles pass through the center O. So what is the ratio? So we want to find the ratio of the combined area of two semicircle to the area of a circle O. So combined area of two semicircle become one circle. So we just want to find what is the radius of this circle. Okay, so this circle radius is let's say, I think this is 1, -1, so this is 1, right? This is 1. Okay, so this area is pi 1 square. Okay, so over pi, oh, this r is 1, yeah, 1 square. Pi 1 square over, so what is the area of this circle? Circle. So we need to find this radius. Okay, so we say this is 0.11. So we say this radius is 1, 1. It's a square. So 1, 1. This square is 1 square plus 1 is radical 2. So this is radical 2 actually, right? Radical 2. Okay, so its r is radical 2 square. So we find this ratio is 1 over 2. So it says we have two 4x4 squares that intersect at a right angle, bisecting their intersecting side. Okay, so this means if there's 4x4, so if there's 4, then this here's 2, here's 2, right? Okay. Okay, so it says a circle's diameter is the segment between the 2 points of intersection. So this, the intersecting here, this is diameter. So here we have a circle. Okay, so what is the question? Questions, we want to find the area of the shared region created by removing the circle from squares. Okay, so we need to find the area of a square. Oh, so we just extend, let's say, extend this, a square. I think is, yeah, there's a point just on the circle. Okay, okay, so we know this is 2, this is 2, this is 2, here this is also 2, right? Okay, okay, and then we can find this diameter equal 2 radical 2, right? Or radius is radical 2. Okay, so now we want to find what is the area for these 2 squares. So these 2 squares area, we can say this equal. So we say we should have some overlap. So this equal like this square, this plus we have this small, there's 3 parts. So this we want to find area. So total area is, let's say, so this square 4 multiply 4 plus we have 3 of the small square. 3, so this is 2 by 2. 2 times 2, right? Okay. Then minus this so-called pi r squared. Pi 2. Okay, so this equal actually 44 plus 12 minus 2 pi. So this equal 28 minus 2 pi. Okay, so this is quite the same as the problem. We want to find the area of the shared region. So shared region, so we can shared region equal 6 square minus 4 of this a quarter of this circle. So just equal this equal square minus a circle. Okay, so this square, so what we want to find? So the square, let's say 4 circle of radius 3. So this is 3, this is 3. Okay. Okay, so we find the square is 3. This is 6 square. 6 times 6, this area of a square, the minus 1 circle pi r is 3, right? 3 square. Pi r square r equals 3. So this is 3, right? 3, okay? So this problem also we want to find area for this region. So this area equal, we say this equal this area, this is the quarter of this circle minus this rectangle, right? Okay, so this so we need to find what is the radius for this circle. So D is center, B, so AD equals 4, CD equals 3. Okay, so we can find this R equal 5, 3, 4, 5. Okay, so this region shared region area equal pi r square, but here we only a quarter of them, right? So minus this rectangle 3 times 4. Okay, so for this problem, we want to find what is the value of the ratio. So we find the ratio of the area of the shared region to the area of one of the small circle. So this small circle is very easy. Small circle area radius 1. So this small circle area is just pi, right? So we just need to find this area of shared region. Okay. So this shared region equal, we say equal this. Like this semicircle. I'm sorry, semicircle minus 2 of them. So minus 2 is circle. So put it together, just one circle. So this equal half of the area for this semicircle. So this equal half pi r. Here is r is 2, like 2 square. So minus one small circle pi 1. So over pi, right? So it's the ratio. Okay. So this equal, cancel the pi. This equal 2 minus 1, 1, or 1 equal 1. So let's check. We have answered the 1. Yeah, so 1. Okay, so now let's consider some 3D geometry. 3D. So let's consider this problem. So we have 6 cubes, each an inch on each side. So there's each cube is 1 by 1 by 1. So they are put together just like that. Okay, fasten together as this. Okay, so we want to find what? Find the total surface area, include the top, bottom, and side. So it's also this problem surface area. We have 3 sides, like face us like this. 3 sides. This one. So we have all surface. So we just check it. Let's see. So such a problem. So we just check these 2. Okay, there's 2. Okay, so these 2 put together, surface area equal. So top is 2, bottom is 2, 2. So 2. So we have, let's see. So that's equal 2. Top is 2, bottom is 2. Yeah, 2, 2, 2. 2, 2, 2. Okay. Okay, 2, 2, 2 plus 2, yeah, 2, 2 plus other 2. So here, there's 2, there's bottom 2, and this left side 2, like here we have 2, right? 2 plus 2 plus 2 plus 2 plus 2, and plus this one, this one, plus 3. So we cannot count for that one, right? Okay. And for this 3, let's check this 3. Okay. This 3. Surface is, so let's say top is 1. Bottom is 1. And side, so that side face this way, so that's equal, not 3 equal 2, right? 2. And this way, watch this way, 3. And that way is also 3. And this way, so 2. Then excuse me. So then for this one, so for this cube, okay, for this cube, okay, so we have 1, 2. We just have 6, but we have 5. Yeah, but we cannot count for that one. Plus 5. Okay. Mm. Mm. Okay, so for this problem, it says 3 dice with faces number 1 to 6 are stacked as shown. So 7 of 18 faces are visible. So those are visible, leaving 11 faces hiding. We have a back one, bottom one, and between. So the question is the total number of dots not visible in this view. So we find in this view what the what is the number of dots we can see. So we can add them up, right? So we can see is just the 1 plus 2 plus 4 plus 5 plus 3 plus 6 plus 1. So what we can see is thus 1, 2, 3, 4, 5, 6 plus 1. So this equal, let's say 1 plus, so we just do this 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 1. So this equal with the 7, 7, 7. So this equals 37 plus 1, 22. Okay. So 22 we can see. Then how many we cannot see? So we say totally. So that for each one is just 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, this equal 7, 7, 7, 21, right? So we not see just 21 multiplied 3 minus 22. So this equal, we can cancel 1. So this equal 21 multiplied 2 minus 1. We can cancel the 21. Okay, so this equal 42, 41. Okay. Okay, so this problem is let's say we make this box from a rectangle sheet of cardboard. So the way is just like that. We have like here the 20, here the 30. So we just cut these corners, cut those. Okay, so then we can make such a box, right? Okay, so this is the 5, yeah, 5. So this, what is surface area? What do we want to find? So here we can find the volume of this box, or the surface area of the interior of the box. So surface area of the interior of a box. So we can say like this equal like we have 5 sides. This one, this one, this one, this one, this one, this one, this one. Okay, so this we say, so we just find. Okay, so if the 30, then let's say this is 5, Then what is this one? So 30 might become 20. Yeah, so this is 20. And here 20 cut is 5 become 10. So this is 10. Okay, so just like that. So we can find the area is so here this one is 5 times 20. So 5 times 20, 5 times 20. We have two of them, right? So plus so here 10 times 5, 10 times 5, and 10 times 5 we have two of them, and plus bottom is 20 times 10. Okay, so this is equal, so this is 10 times 20, 200, and this is 100, right? 100, and this is 200, so this is 500. Okay, so this is cylinder. So let's say so here this radius 10 and height. This is 5. So we can have this cylinder. So we can find what is the volume for this. What is volume of a cylinder? So okay. So this volume is equal base area pi 10 square multiply h5. So here maybe we review this like, okay, for this cylinder, suppose this is R, this is H, then the volume is this base area is pi r squared times h. Okay, so this is which cylinder has twice the volume of this. So twice is so which one volume equal 2 times this, right? So just like pi times 10 squared times 10 3. Which one can be like the volume like this? So very clear this one, right? D. Oh no, not D. This is 10 5. So here, if this is 10, this is also 5 10, then double. So 5 20 10 10. Oh, we see this just this, right? Pi 10 times, yeah, pi 10 square times 10, yeah. So there's a problem. It says a cube of edge 3 is cut into n small cube, not all the same size. If the edge of each of the smaller cubes is a whole number, then n equal which number? Okay. So the problem is we have a cube. And the edge is 3 by 3 by 3, right? 3, like that. Okay, we have such a curve. So we cut it into n smaller cube, but not all the same size. So we can cut into like we can cut this way. We can like one. We can cut it this way. So let's say if the edge of each of a smaller cube is a whole number, so it can be only 1 or 2, right? So let's say can be only 1 or 2. So if we can cut 1, so maybe we can do this way, like if we cut 1, just 1, just cut this way. So 1, 1, okay. Okay, so in this way we can make n equal 27, right? We can take it from big cube, we can cut 27 small cubes. But here it says not all the same size. If all the same size, 27. So not all the same size. So this means we can cut 2 by 2. So let's see. So this here we get 2 by 2. Suppose, okay, 2 by 2. Okay, so this is 2 by 2. So if we cut 2 by 2, so we have many smaller one left, right? So those one can only be cut 1 by 1 by 1. So how many of them? So we can check like if this one, if we cut 2 by 2 by 2, then how much volume left? So we say volume left equal total volume 27 minus 2 times 2 times 2, right? Equal, so 27 minus 8. So this is equal 19, right? So for those 19, so we can cut over them. Cut this. We can cut 19 cubes with side 1. Okay, so total n should be this one. This one is 2 by 2 by 2 plus, so 19. So 19 is 1 by 1 by 1. So totally we can get 20 of them. Right? Okay. Okay, so there's a problem. The numbers on the face of this cube are consecutive whole number. So consecutive, so here we have 3. So consecutive number, maybe just like that. 11, then 12, then 13, then 14, then 15, then 16. We have six faces, right? Let's say, yeah, 1. Okay. But maybe not those numbers. So let's say the sum of the 2 numbers on each of the 3 pair of opposite face are equal. Okay. So let's say, if this 11, so we need to find what the equal number is. If this 11, so what is the number here? So the sum of 6 number on the cube is that. So what? The sum of 6 on this cube. The sum of the 6 numbers on the cube is. So we need to find these 6 numbers. So this 6 number can be those numbers, those 6 numbers, or can start from 10. So we reach, let's say, so here we see the consecutive whole numbers. So we just check which case satisfies us. So we just check. Maybe so we. I put this number smaller. If 10, 11, 12, 13, 14, 15. Does this work? So we say if this works, then the number can be like this. This plus this, this plus this, this plus this, right? If the number is this, like 11, 12, 13, 14, 15, 16, then should be like that. 11 to go to 16, 12 go to 15, 13 go to 14. So we just check which one. Okay, so this one, let's say 11, this one 11 should go to 14, so no, should be this one, right? So 11, so we put 16 here, 12, 15, 15, 12. Okay, so the sum is just this. This is 6 number. So this equal 27 multiply 3, right? So 81. Okay. Okay, so for this problem, this is each corner of rectangle is rectangular problem is cut off, just cut off. So how many edges does the new finger have? Okay, so this is just like a cube. We cut it. So let's check it. We just check cube. Same, right? Okay, so look at this one. So if we cut this, so we can have like this. So how many edges? Like cut, so here cut. Okay, like cut how many edges? So this means the total original edge. So original edge is let's say how many the cube, like how many edges. Okay, how many edges? 1, 2, 3, 4, 1, 2, 3, 4, 1, 12, right? Original 12. So plus some new edges. So here we produce 3 of them, right? 3 new edges. Okay, so each corner we produce 3. So this equals 3 multiply how many? We have 8 of them, right? Yeah. Okay. So this is the edge. Let's see what is the answer. So equal 12 plus 24, 36. So we have this answer, so should be 36. Okay, so we can stop here. So this is geometry lecture video for second video.